In this activity, we will be looking at the conditions for equilibrium. And the conditions for equilibrium is that the net torque and the net force on a system must equal to zero. Here we'll be looking at the net force on a rod with a mass suspended in the air. Here are the equipment that we're going to be using. First thing we want to do is to attach the clamp so that we can support the rotary sensor. So go ahead and connect it to the edge of the bench. This would be the best position as we will need to have the rod in a vertical position to begin with. Okay, so go ahead and connect the shorter ramp, the rod to the clamp, and then go ahead and attach your rotary motion sensor onto the rod. The rotary motion sensor will be used to determine the angle of the rod from the horizontal. Okay, so go ahead and slide it in. As you'll see later on in the video, we're not going to be using the side of the rotary sensor with the pulley. We'll want the other side to attach the ramp. I will make this correction later on within the video. Our setup is a little bit different than the one on PASCO because we're going to be using the Science Workshop equipment. So just as before, the yellow input goes into the input 1 for the digital inputs, and then the black goes into input 2. This must be the case if we want to be able to measure any angular measurement. So here I've corrected the position of the rotor motion sensor, and now what we want to do is to attach the rod with the screw that came with the rod to the axle of the rotary motion sensor. As you can see here, I'm having a little trouble connecting those. If you have a lap partner, it'll be a little bit easier. What I found out, it's easier to simply rotate the pulley in the back to screw in the rod to the rotary motion sensor. Okay, so make sure that's snug so that as you rotate the rod, the rotary motion sensor rotate as well so that we can have angular measurements. Next, what you want to do is to attach the force sensor onto the second rod and stand. Okay, and this is what we're going to be used to measure the tension needed to support the rod in its equilibrium state. This is an analog sensor, so this go into your input A, your analog input A. So make sure you align the pins of that plug correctly before inserting it into position A. The length of the string needed here is not really important, so just go ahead and cut off just enough that you can be able to work around your setup. So here I have maybe about 50 centimeters or so. What I'm doing here is to creating a hook so I can hook it onto the force sensor hook, and you'll want a hook so that you can remove and add the string at random. The button on the side is a tear button that you'll use to zero the force sensor whenever there is not a tension onto the force probe. I suggest that you guys zero the force sensor every time before you take a measurement. Next, I then loop the other end of the string through the center of the rod, and there's a slot there for you to do so and secure the string to it. As you can see there, the rod is with the force sensor begin to slide. Later on, I'll put some additional mass for support onto the rod. Okay, and this is basically your setup. Okay. Um, what you want to do, as you saw in the image, is to have that string as horizontal as possible. We want the tension to be horizontal, and that's why there is a level provided there as well. If you take a look at what I have here, the string is not horizontal, so there's a groove there within the level that's used to use as a line level for our strings. So go ahead and move the force probe up and down or to stand back and forth in order for you to have the string as horizontal as possible. Okay, so that's what I'm doing here. And you want an angle other than a vertical position. The vertical position would not be of interest here. Somewhere between, I would say, 30 to 60 degrees would be best for this activity. Okay, so once we have it horizontal, if we take a look at a free body diagram, we have the weight of the rod, the weight of the mass, and the tension in the string. There's some additional forces there at the center of rotation, but that's not of interest to us, and we'll explain that later on. The moment arm R1 is the distance from the axis of rotation to the tension and the weight of the rod, and then the moment arm R2 is the distance from the center of axis to the center of the mass is being suspended. The torque then is Rf sine theta. So we need to measure the angle between R1 and the tension and the weight of the rod, and the angle R2 between R2 and the weight of the rod, and that's the purpose of our rotary sensor. So to make this measurement, we want to start from horizontal, and that is our 0. You hit collect. You want to tear the force sensor again, so that's 0. It's close to it here. It doesn't completely get to 0. And now when we begin to rotate, we're measuring the angle from the vertical position, the downward vertical position, and we hook that onto the force sensor. Now you'll see that there is a tension in the string. It's negative because we're pulling on the string, and the angle is 134 from the vertical. So you will need to determine the angle from the horizontal. So 134 degrees is the angle of rotation from the vertical, but we want it from the horizontal.